project consists of three parts. Response of fiber break grating towards temperature change is studied using the synthesis method by optimizing the FPG physical parameters. A PID resistive heating system and a FPG measurement system are constructed to characterize the FPG temperature sensor. A FPG temperature sensor package is designed to protect the FPG and to reduce the measurement errors. Is a fiber break grating. Fiber break grating (FBG) is the periodic change of refractive index that form inside a single mode optical fiber core permanently. There are many types of FBGs, such as uniform FBG, chirp FBG, sample FBG, and tilted FBG. What FBG can do? FBG can reflect certain wavelengths of light while allow others to be transmitted. As the result, the reflected light will form a reflection spectrum. Why we synthesize a FBG? The FBG physical parameters can be designed from a desired FBG reflection spectrum. The changes in FPG physical parameters can be studied when FPG is subjected to different temperature and strain. A FPG with unknown design can be characterized and reproduced. A FPG measurement system is constructed to read the reflection spectrum of FPG. The FPG is heated to different temperature to observe the change in the reflection spectrum. For different temperature, the Bragg wavelength for each reflection spectrum is recorded. Bragg wavelength is the wavelength where reflectivity of the FPG is the highest. The recorded Bragg wavelengths are plotted against the temperature. A linear least squares regression line is constructed to determine the FPG thermal optic coefficient. Thermal optic coefficient describes the change in FPG refractive index with an increase of 1 degree Celsius. After obtaining the temperature coefficient, particle swarm optimization algorithm is used to extract the FPG physical parameters from the reflection spectrum which is closest to the regression line. Particle swarm optimization algorithm mimics random flight patterns of a flock of birds when they are finding their food. The particle position indicates the FPG physical parameters, which includes the grating refractive index, the grating period, and the grating length. Each particles have their own velocities which are influenced by the global base position and the individual base position. The extracted FPG physical parameters is used to generate a reflection spectrum and compare to the experimental result. The FPG temperature response at each temperature are simulated using the FPG temperature coefficient and the extracted FPG physical parameters. An experiment system consists of a PID resistive heater system, and a FPG measurement system is constructed to study the FPG temperature response. The PID resistive heater system will control the temperature subjected to the FPG, whereas the FPG measurement system will measure the FPG reflection spectrum. The BID resistive heating system consists of a control circuit and a heating stage. The control circuit consists of an Arduino Uno board as PID controller, 3 thermocouples to measure heating stage temperature, MOSFETs as power modulators, and ceramic resistors as heating elements. The Arduino Uno board will output PWM signals to the MOSFETs to control the power to the ceramic resistors. The heating stage is designed to hold the FPG in position to allow heat from the ceramic resistors to be transferred to the FPG effectively and to allow the thermocouples to measure the temperature at the heating block. The laser diode driver and the EDFA will output a broadband light. Some light will be reflected from the FPG. Then the circulator will direct the reflected light to the optical spectrum analyzer for measurement. A sensor package for FPG sensor is designed to reduce the effect of environmental errors. The magnets allow the sensor to attach to metal surface easily. The sensor package is designed so the FPG can contact firmly to the target surface and to avoid sudden air drift. The lightweight sensor package also protects the FPG, allows multiplexing of FPG sensors, and allows sensor attachment to slightly curved surface.